Here's problem 2. If alpha and beta are measures of two first quadrant angles, so they're in the first quadrant, find the exact value of each function. Here it says the sine of this, find cosine of alpha minus beta. We're going to apply the formula. We know if we're doing that, it's going to be the cosine of alpha times cosine of beta plus sine of alpha plus sine of beta. And then we're just going to fill it in. So to start this, the first thing we do is we're going to look at our alpha triangle and our beta triangle. We have two triangles and we're trying to add the angles, or in this case subtract the angles, and figure out what the cosine is. So let's look at the alpha triangle. Here's the alpha triangle. It's in the first quadrant, so it's like this. Here's alpha. It says the sine is 12 over 13. So sine is always the opposite over hypotenuse. So opposite is 12, hypotenuse is 13. We're going to need to find this bottom piece. Well, we'll use the Pythagorean theorem every single time. This missing piece squared plus 12 squared equals 13 squared. I'm going to tell you right now that's going to come out to be a 5. 5 squared plus 12 squared equals 13 squared. Let's come to the beta triangle. Beta triangle. Here's beta right in here to 90 degrees. It says the sine. Again, sine is opposite over hypotenuse. So opposite is 40, hypotenuse is 41. So we would say, again, a squared plus 40 squared equals 41 squared. And then we solve for down here. This is going to be a 9. Because 9 squared plus 40 squared equals the hypotenuse value squared. So now we have our triangles. That's the main thing that we always start with. Now we just apply the formula. It says, tell me the cosine of alpha minus beta. The cosine of alpha minus beta. The formula says do cosine of the first angle alpha times cosine of the second angle beta. And since that's a minus, the formula says you need to do an addition here when you're doing cosine. If it had been sine, it would have stayed. It would have stayed the same symbol there. It says now do sine of alpha times sine of the beta. So I know cosine, I always love that because it's super easy. It's the cosine of the one angle times the cosine of the other plus sine of the alpha times sine of the beta. Could be subtraction if that had been addition. Now, come to it says cosine of alpha. So here's alpha. Cosine is adjacent over hypotenuse, 5/13. Cosine of beta. Here's the beta. Cosine is 9/41. Plus sine of alpha. So here's the alpha. Sine is 12 over 13 times sine of beta. Here's the beta. Sine is opposite, 40 over 41. Okay. So now all I got to do is multiply these, and then add them together. The denominators will always be the same in these problems for cosine and sine when we're doing a double angle here, or adding two angles. 5 times 9 is 45. 13 times 41 is 533. Plus 12 times 40 is 480. 13 times 41, again, the 533. Add them together. 45 and 480 is 525 over, denominator stays the same, 533. There's our answer to problem 2.